Here we are going to find the wavelength of laser using a grating. As all of you know, laser is an acronym for light amplification by stimulated emission of radiation. It is characterized by monochromaticity, directionality, coherence and high intensity, and that is why we are using laser for this experiment. Also, a diffraction grating is a medium on which a number of lines are drawn such that the lines act as opaque space and the space between lines act as space through which light can transmit. As you can see, the grating that we used here has got a grating element 15,000 lines per inch. We are using this semiconductor laser to perform this experiment. We placed a grating in front of this laser and we also placed a screen just opposite to this laser so that we can see the diffraction pattern there. And we use this scale to measure the distance between screen and grating. As we switch on, we can see the diffraction pattern on the screen. So you can observe central maximum, primary maxima, secondary maxima on the screen. As you can see, this is the spectrum and we can mark central maximum, primary maximum on left hand side, primary maximum on right hand side, secondary maxima on left hand side, secondary maxima on right hand side. The distance between central maximum and first order principal maxima on both sides are measured. Also, the distance between central maximum and second order maxima on both sides are measured for calculation. We have to measure the distance between screen and grating, which can be taken as capital D. We can adjust the value of D such that the spectrum completely falls onto the screen that we are using. Here the distance is measured as 25 cm. For repeating this experiment, we can change the value of capital D. As you can see, when we change capital D, the diffraction pattern will also get changed. Coming into the observation part, we have the tabular column. There it is shown that order number 1 and 2, that means primary and secondary maximas. For capital D is equal to 25 cm, that means the distance between screen and grating is 25 cm. For that distance, the distance between central maximum and first order principal maxima on left hand side is measured as 9 cm, and for right hand side it is measured as again 9 cm. And for a distance 21 cm, the LHS reading is shown 7.5 cm. The RHS reading is shown 7.5 cm again. And for second order, for a distance 25 cm, the LHS reading is found to be 21 and RHS reading is found to be 23. So we have taken the mean and substituting into the equation root of x square plus d square, we will get values and we can easily find sin theta from that. Then we will get sin theta for first order and also sin theta for second order, and we can find lambda is equal to d sin theta by n, where n is the order. So we have already found for first order and also for second order, and d here is the grating element. So from the grating it is easy to find grating element. That means it is shown there as 15,000 lines per inch. So we can easily find d as is equal to, for 1 inch we can substitute 2.54 centimeter. So 2.54 centimeter divided by 15,000 will give you the grating element. So substituting the values of d, sin theta and n, you will get lambda, the wavelength of the laser that we used.